In this video, we will be talking about alkenes. To start, the general formula of an alkane is CnH2n plus 2. Now the general formula of an alkene is CnH2n minus 2 times the number of pi bonds and the number of rings. And this right here is called the degree of unsaturation, which is the total number of pi bonds and rings in your structure. So the first question asks, what is the IUPAC name of this structure along with the degree of unsaturation? So for this structure, we have 2 double bonds and a chlorine substituent. So in order to get the name, we need to figure out the parent chain, which is the longest continuous carbon chain, which is going to be right here. So that is going to be 7 carbons long. However, we have 2 double bonds, and these are going to get priority in naming. So at the end we have diene. Now we need to note the position of the 2 double bonds, which needs to have the lowest number. So we will go from this carbon. So there's a double bond at 2 and at 4. And we have a chlorine at the 1 carbon. Now we also need to determine from the name if these double bonds are cis and trans, or E and Z. This first double bond here at number 2 is cis, so it's going to be Z, and this one here is trans, so it's going to be E. So the total name is 2Z4E 1-chloro-2,4-heptadiene. And the degree of unsaturation is number of pi bonds and rings, and we have 2 pi bonds, so we get 2 degrees of unsaturation. The next question asks you to draw the structure in the condensed formula of propyl-vinyl ether. So we have an oxygen here, and we can draw a propyl group, and then we can draw a vinyl group, which is this. This is your vinyl group. In the condensed formula, from left to right, is CH2, CHO, CH2, CH2, CH3. Now the next question asks you to do the same thing, but for allyl ether. And allylic group is going to be like this. And we do the same thing to the other side. So this is an allyl group. And the condensed formula is CH2, CH, CH2, O, CH2, CH, CH2. Which of these is an electrophile? So an electrophile is generally going to be anything that is positive. That means we can eliminate the chlorine ion and the hydroxide. With CH3NH2, we have a lone pair, and we know this is a base, so it is not going to act as an electrophile. So the correct answer is AlCl3. And if you recall, AlCl3 is a Lewis acid. The last question, which of these is a nucleophile? So for this one, we have BH3, and we know that's a Lewis acid that will not behave as a nucleophile. We have hydronium, which is positively charged, so that is actually going to behave as an electrophile, not a nucleophile. We have H2SO4 and NH3. And so the correct answer is going to be NH3, because again, we have a lone pair here, and H2SO4 is a common strong acid, which will not behave as a nucleophile. That concludes the video on alkenes.